Hello, today I'm going to read about tokenization in Transformer version 5. This is my reading session to improve my speaking. Let's get down to this. Transformer version 5. Uh, Last time I read about it and it was quite interesting. There were many interesting changes here. Oh, I didn't record the rate, but there was interesting change there. Now let's read about the tokenization in Transformer, which is simpler, cleaner, more and modular. It was published in December 18, 2025. That is today. Okay. Now, Transformer V5 redesigns how Transformer to tokenizer work. The big tokenizer reformat separated the tokenizer design from trained vocabulary, much like how task PyTorch separate neural network architecture from loan words. The result of tokenizer is you can inspect, customize, and train from scratch with far less friction. TLDR, this blog post explains how tokenization works in Transformer and why V5 is a major redesign with cleaner internal, a clean class hierarchy, and single fast backend. It is a practical guide for anyone who want to understand, customize, or train model-specific tokenizer instead of treating them as a black boxes. Table of content. Let's start. For export, if you are familiar with the concept, you and understand what want to understand the changes in version 5, go to version 5, separate tokenizer architecture from train vocab. Before diving into the changes, let's quickly cover the what tokenization does and how it pieces fit together. Okay, what is tokenization? Language model don't read raw text. We all know that. They consume the sequence of integer, usually called token IDs or input IDs. Tokenization is the process of converting the raw text into these token IDs. Try tokenization player out here to visualize the tokenization. In a simpler term, language model do not work directly with the words. They work with the number, and we have to convert what we're trying to say it, that means words, to the number. And it is not a simple one-to-one mapping, but rather some sort of mathematical model is going on, and it represent here like this is test. Simple. Here is this token, this space and is second token, and there is a test, and there is a second two space is treated as one token, and the simple with the small space in front. Okay. Here if you look here, the above text is treated as the number 576, 374, 196, and 256 and 4382. There are 5 tokens that is used to represent this full sentence as it is without changes. Yeah, we can transform the our text into the token and token to the exact same text. It is a reversible process. Okay. Tokenization is a broad concept used across the natural language processing and text processing generally. This focuses specifically on tokenization of large language models using the transformer and tokenizer libraries. Using the Hugging Face transformer, it is simple to initialize the tokenizer. We import the auto tokenizer from the transformer, and we initialize the tokenizer by auto tokenizer dot from preset and gives the model name, and it will automatically infer the type of the model and download the tokenizer for that model. Auto tokenizer is the class that infer the type of the tokenizer for that model. For here, it will use the slow LLM 3 billion parameter tokenizer. Here, given the text, we directly pass the text, we initialize the text, we pass the text to the tokenizers function, and it gives the tokens, and we can inspect the token IDs. That means what is it when it is converted to the token. We can also convert the token to words. Yeah, converts IDs to token. Yeah, G words above is a single token that represents the character sequence word with the spaces. G is the particular embedding for the spaces. G, it's not a G. G in a colon in upper. I don't know what it is, but like a tick in at the upper G. A token is smallest string unit the model sees. It can be a character, word, or subword. Chunk like play or ing. Your double hex has is a pattern. Do not worry if you do not completely understand now. The vocabulary maps each token to the token ID. This means it uses the we have to know because the tokenizer is trained using the word using the word character or whole, what can I say, whole data set. Yeah, and in the data set not all the words can be included in data set, and there are many different words that are reinvented which cannot be recorded in the dataset. But when we prompt the model, when give that word, the model should be able to analyze it. So for that we for that the tokenizer do not completely mark the word as a token, but it splits. There are many way of tokenization such as BPE and a word piece. I think this double hex INZ is the word piece token from the word piece. Double hex means there is it is not a single, and double hex means there is it is the token for the word which come before it. Like is when I say traveling, travel is one token, ing is another token, and we have to know that travel and ing are should be combined to get the traveling. So double x means that in the simpler form. Sorry if what I say doesn't make sense, but let's read it. From the transformer import auto tokenizer, we can it is the same as above, and we can also see the vocab, that means mapping between the token and the token ID. A, to, a good tokenizer compresses text into the smaller amount of tokens. Fewer tokens means more usable context without increasing the model size. Training a tokenizer boils down to the finding the best compression rules for the dataset. For example, if you work on the Chinese corpus, you can sometimes find very nice surprises because the Chinese is there are many characters in Chinese. I think that is the surprise they are talking about. I don't know. Let's see what is the surprising thing that they have talking about. I don't know why I'm spending my Friday night looking at a token, but here we are. The Baichun token has the 64 vocab size, of which 28k contains Chinese character and 1.5k are greater than or equals to 3 character. Perhaps surprisingly, we find epidemic prevention, coronavirus diseases committee, Xi Jinping, coronavirus, nucleic acid amplification testing, new coronavirus, Boer marks, Communist Party, People Public Republic of China, Communist Party of China, General Secretary Xi Jinping. Copyright belongs to the original author. Copyright belongs to the original author. The list of the 1.5 Chinese token can be found here. Hmm. Here is the single token, means this whole sentence is being this single token. Oh, that is surprising because it the tokenizer allocated it token ID because it appears so much time in the training data set that it assigned the token. You can easily imagine how much time that the same sentence come many times here, same phrases. The tokenization pipeline. Tokenization happens in stages. Each tokenization is stages transform the text before passing it to the next stage. Normalizer. What is the purpose? Standardized text, lowercasing, Unicode normalization. What is space cleanup? For example, hello world to the hello world. We are lowercasing the all the word, all the character. Pre-tokenizer split text into the preliminary chunk. If there is hello world, we split into the two particular word based on the given syntax. For example, here we are splitting between the spaces. There is hello and there is wall. Model applies tokenization algorithm. BPE, Unigam. There were different type of tokenizer that were invented, and BPE is the one of the best tokenization. I can say best tokenization, but it is most widely used tokenization in the LLM. There can be better, but it is widely used, and it is one of the best also. Yeah. Post processing, add special token. BOS EOS padding means beginning of sentence, EOS means ending of sentence. Because we are training the model, we models need to know the beginning of the sentence and end of the sentence to uh, get the idea of when to end or begin the sentence during the inference, so that model do not generate the token if there is no signal to signify it to stop it. Yeah. Decoder convert token ID back to the text means when the model inference that they gives the answer in the token, we but we cannot understand the token. We need some readable way to evaluate it faster. So it is mapping from that token ID to the token. Each component is independent. You can swap normalizer or change the algorithm without rewriting everything else. You can access the Rust based tokenizer through dash tokenizer. We go more depth about it in this section. It's another blog post. I think I should read it, but at another time. Okay. From transformer import auto tokenizer, we are initializing the auto tokenizer from the Zema 3 270M IT. Tokenizer dot is equals to, it gives the normalizer use in here, it gives the pre-tokenizer use in the tokenizer. There are different tokenizer models, post processing use unit. Yeah, what type of post processing is being used, what type of decoder is being used, and decoder means converting from the token ID to token. Tokenization algorithm. The following algorithm dominate the model tokenizer: BPE, byte pair encoding. Iteratively merges the most frequent character pairs. This algorithm is deterministic and widely used. Uh, it was introduced by GPT, if I'm not wrong. Print tokenizer dot tokenizer model BP. Unigram. Unigram takes the probabilistic approach, selecting the most likely segmentation from the large initial vocabulary. This is more flexible than the strict BP. Unigram means it was, if I remember right, it first tokenizes the word, and it after tokenizing the whole word, it tries to tokenize the phrases, that means most frequently um, bigrams to word, and it tries to tokenize all the word initially, and after it finishes it tries to tokenize the most repeatedly repeated two words, if I'm right. Yeah, I don't know, I forgot, but if I remember correctly, that should be it. WordPress resembles BP but uses the different merge criteria based on the likelihood. It was WordPress was implemented by the Google, and the implementation, if I remember correctly, the implementation, there is no open source implementation, but they have given the implementation which Hugging Face used to create to recreate the BP WordPress. Accessing tokenizer through transformer. The tokenizer library is Rust-based tokenization engine. It is fast, efficient, and completely language model agnostic. The library handles the mechanism of converting the text into the token ID and back. The tokenizer library is a general purpose tool that implements the tokenization algorithm but does not implement the convention that connects those algorithms to the specific language model. Consider what happens when the tokenizer directly when you use tokenizers directly with the Sol LM 330B 3B model. The output is raw tokenization. You get the token ID and string pieces they corresponding to it, nothing more. Now consider what is missing. The small LM3B is the conversational model. When you interact with it, you typically structure your input as a conversation with the role like user and assistant. The language model expects the special formatting tokens to indicate this role. The raw tokenization library have no concept of this. How do you bridge this gap between the raw tokenization and model requirement? The transformer library bridges this gap. The library is primarily known as a model definition library, but it also provides the tokenization abstraction layer that wraps the raw tokenizer backend and adds more model-aware functionality. Here is the same tokenization with the transformer wrapper. Tokenizer. We are initializing tokenizer of a small LM3B. Prompt. Give me the brief explanation of gravity in the simpler term. Message. We are providing the message in the role is user and content is the prompt. Tokenization. Apply the chat template. Messages. Tokenization false and add generation prompt true. And in print trend, that means in the instruction in the current LLM, simply tokenization, the tokenizing the what we are given is not sufficient, because in multi-generation conversation the model has to know which one is from the human and which is the beginning of and signal to indicate the beginning of the sentence by the human and the end of the sentence by the human, and then there is the assistant provides some output which can be fed again to the models to generate the response. Yeah. So we typically uses this format to signify the what to use in the typically this is use standard way of using the chat interface in the LLM. And there are many intricate tokens that need to be input inputted, but it is not done by the user, and user don't have to know that. There is the functionality of the tokenizer, which apply that same template. Yeah, yes. I'm start system, I'm start user, give me brief application of the gravity in the simpler term, I'm int, and I'm start assistant. This is added by the tokenizer itself. We do not have to know the specific details, because they are the predefined token, like beginning of the sentence, end of the sentence, that you may use in a encoder or bird. Yeah, bird like system. Yeah, at that time you may use it, but here this can be different for the different model according to how they train it to give the model about where is the start of this system and how it is the end of the system, and following format. Notice how let's read it. Notice how the special token like I'm start and I'm int are applied to the prompt before the tokenization. This is useful for model to learn where the new sequence start and ends. The transformer tokenization adds everything the raw library lacks. Chat template application. The apply chat methods format the conversation according to the model expected format, inserting the correct special token and delimiter. The automatic special token insertion. Beginning of the sequence and end of the sequence are added where the model expects them. Truncation to the context length. You can specify truncation is equal to true, and tokenizer will respect the model maximum sequence length. Batch encoding with padding. Multiple input can be padded to the same length with the current padding tokens and direction. A return format option. You can request the Python tensor. Return tensor is equal to pt numpy array and others. Transformer implement tokenization API that is most commonly used in entire ML community. Encode, decode, convert tokens to IDs, etc. Tokenizer class hierarchy in Transformer. The Transformer library organizes the tokenizer in the class hierarchy. At top sits the base class that defines the common interface. Below it, the backend class that handles the actual tokenization using the different tokenization engine. At the bottom, the model specific classes configure the backends for the particular model. Pre-tokenizer base, tokenizer backend, Python backend. Tokenizer backend means I think it is implemented in Rust. Llama tokenizer, Gemma tokenizer, and to Python backend, CTRL tokenizer, Canyon tokenizer, sentence piece backend means Sliglip tokenizer, and broad tokenizer. The class hierarchy of the tokenizer inside the transformer. Pretend tokenizer base defines the common interface for all the tokenizers. Pretend tokenizer base is the abstract base class for the tokenizers in the transformer. It defines the interface that every tokenizer must implement. The base class handles the functionality that does not depend upon the tokenization backend. Special token properties. Properties like BOS token, EOS token, paired token means beginning of sentence, end of sentence, and paired token, and the UNK unknown token are defined here. These properties provides the access to the special tokens that model use to mark the sequence boundaries and handle the unknown input. Encoding. The call method, encode and include plus method are defined here. The model expects the text input and returns the token ID along with the attention marks and the other metadata. Decoding interface. The decode and the batch decode methods convert the token ID back to the text. Serialization. The shape return and prompt return method handle the downloading the correct files, reading the information, saving the tokenizers to the chat template. Support the apply chat template method lives here. Formatting the conversation according to the Jinja template is stored in the tokenizer configuration. Every tokenizer in the transformer ultimately inherits from the pre-tokenizer base. The base class ensures the consistent behavior across all tokenizers regardless of which backend they use for the actual tokenizer. The tokenizer backend wraps the tokenizer library. Tokenizer's black backend is the primary backend for the model tokenizer. It inherits from the pre-trained tokenizer base, wraps the ROS-based tokenizer library. The class stores the ROS tokenizer object internally. Tokenizer backend, pre-trained tokenizer base. Initiate means tokenizer object. Self tokenizer is tokenizer object, which is the ROS tokenizer. When you call the tokenizers including method on tokenizer backend, the class delegates the actual tokenization to the ROS backend. Means what is happening is in the ROS backend. The ROS backend performs the computationally intensive work while Python wrapper adds the model aware features on top. Because ROS is fast, it is compatible to the C. Yeah. Many model specific tokenizers inherit from the tokenizer backend. Example include llama tokenizer and gamma tokenizer. They have both have the ROS backend. This model specific rule configure the backend with the correct vocabulary. Most rules specific token normalization settings per their respective models. Python backend provides the pure Python mixins. Python backend inherit from the pre-trained tokenizer base and implement the tokenization in the pure Python. This class is alias of the pre-trained tokenizer. The pure Python backend exists for several reasons. Custom tokenization logic. Some models require the tokenization behavior that does not fit standard tokenizer pipeline. Legacy compatibility. Older model implementation may rely on the Python specific behavior. The Python backend is lower than the ROS backend. For most use cases, the ROS backend tokenizer backend is preferred. Model specific tokenizer that inherits from the Python backend or its alias trained tokenizer includes some older or specialized model like CTRL tokenizer, Canyon tokenizer. SentenceBeans backend handles the SentenceBeans model. SentenceBeans backend inherits from the Python backends and provides the integration with the Google SentenceBeans library. SentenceBeans is alone standalone tokenization library that many model use, particularly those trained by the Google. The backend wraps the SentenceBeans processor. Model uses SentenceBeans tokenizer inherit from the backend. Model that use SentenceBeans inherits from this backend. Example include the Siglip tokenizer, BART4 tokenizer. The SentenceBeans backend inherits from the Python backend rather than from pre-trained tokenizer base because it shares much of the same interface and padding truncation logic. Auto tokenizer automatically selects the correct tokenizer class. Auto tokenizer is the recommended entry point for the loading the tokenizer. It automatically determines the tokenizer used class to use for a given model and returns an instance of that class. Behind the scene, auto tokenizer perform these steps. Download the tokenizer configuration from pre-trained method, fetches the tokenizer configuration from the hub or the local directory, identify the model type. The configuration contains the metatype of the metatype that identifies the model type like GPT-2, Llama, BERT. Look up the tokenizer class. Auto tokenizer maintains the mapping class tokenizer mapping names that maps the model types to the tokenizer class name. GPT to the GPT-2 tokenizer, Llama to Llama tokenizer, BERT to BERT tokenizer. Initiate the correct class. Auto tokenizer imports the appropriate tokenizer class and calls it from pre-trained method. Return the configured tokenizer. You can receive a fully configured model specific tokenizer ready for use. The benefit of the auto tokenizer is that you don't need to know which tokenizer class the model uses. Whether a model uses Llama tokenizer, GPT-2 tokenizer, BOT tokenizer, or this auto tokenizer from pre-trained model name call works. The tokenizer system in the transformer forms a layered architecture. Here, what is the layer architecture? Here is the layer, component, and responsibility. Input entry point. Auto tokenizer automatically selects and initiates the correct tokenizer class. Model specific Llama tokenizer, GPT-2 tokenizer configures the backend with the model specific architecture, normalizer, pre tokenizer, etc, special tokenizer, and settings. Backend tokenizer backend, Python backend, SentenceBeans backend implements the actual tokenization using the specific engine. Base pre-trained tokenizer backend. It defines the common interface and share functionality. In scene, tokenizer Rust, which is implemented in Rust sentence piece, which is not which is compatible with the pre-trained tokenizer base, and pure Python, which is implemented in purely in Python, performs raw tokenization. Version 5 separate the tokenizer architecture from the train bucket. Now, only now he came into the version 5. The most significant change in the Transformer B5 is a philosophical shift in how tokenizers are defined. Tokenizers now work like the parameters NN models, NN dot models. You define the architecture first, then fill it with learned parameters. The problem with before, tokenizers were opaque and tightly coupled. In before, tokenizers were back black boxes tied to train the pretend segments. If you loaded the llama tokenizer fast, you could not answer the basic question about it. Is it PP or unigram? How does it normalize text? What pretend tokenization strategy does it use? What are the special token and their position? The init method gave no clue. You have to dig through the serialized files or external documentation to understand what tokenizer actually did. Class llama tokenizer fast. Pretend tokenizer fast. Init here it's for file tokenizer file clean up for tokenization spaces. Unknown token be beginning of sentence, end of sentence, add BOS, add US, use default system prompt or legacy prefix if legacy is known. You are using the default behavior of the class. Legacy is just true. Yeah. Llama tokenizer as seen in the before transformer. Before also maintain the two parallel implementation for easy pre-model. A slow Python tokenizer, Llama tokenizer inheriting from the pre-trained tokenizer, and fast tokenizer, fast Rust based tokenizer, Llama tokenizer fast inheriting from the pre-trained tokenizer fast. This means two files per model. Tokenization llama.py, tokenization llama fast.py. Code duplication across the hundred of model. Behavioral discrepancies between the slow and fast version leading to the subtle bug. Growing test suite dedicated to verifying the slow and fast tokenizers produce the identical output. User confusion about which tokenizer to use and when. Worst of all, you couldn't create an empty tokenizer architecture. If you wanted to train an llama style tokenizer on your data, there was no clean way to initiate the blank llama tokenizer and fill it with your vocabulary and merges. Tokenizer existed as a loaded segment, not a configurable template. B5 solution. Architecture and parameter are now separate. B5 treats tokenizer architecture, normalizer, pre-tokenizer, model type, post processor, decoder as a distinct from the trained parameters, vocabulary, and merges. This mirrors how PyTorch separate model architecture from learn weight. With the NL model, you first define the layer first. Yes. Architecture define weights initialized randomly or loaded later. B5 tokenizer follow the same pattern. From transformer, import the llama tokenizer, initiate the architecture, llama tokenizer, train on your data to fill the vocab and the merges. Tokenizer.train files means keep the files from which the tokenizer is being trained using the same algorithm as llama. The tokenizer class now explicitly declares its structure. Looking at a llama tokenizer in B5, you can immediately see it uses PPE as its tokenization model. It may add prefix space before text. It special token unknown beginning of sentence, end of sentence sits at the specific vocabulary position. It does not normalize the input text. Its decoder replaces the meta space underscore with the spaces. Now llama tokenizer we are specifying it uses PPE and merges clean tokenization. This transparency was impossible in before, where the same information was buried in the serialization file. vocab, we can also give the vocab, we also give the mergers here. 1.5, one backend, one recommendation path. B5 consolidates the two files into the single file for model. Llama tokenizer now inherited from the tokenizer backend, which wrap the Rust-based tokenizer that was previously exposed as a fast implementation is now the default. The former slow implementation lives explicitly behind the Python backend, and syntax backend remains per the model that require it, but Rust-based tokenization is preferred by the default. This challenges eliminates the duplicate code across the slow and fast implementation. The confusing tokenizer versus tokenizer fast naming convention. Test suites dedicated to checking the slow fast parity. User now can have one clean entry point. Advanced user who need to customize can still access the lower level component, but the library no longer forces everyone to navigate the two parallel implementation. You can now train the model specific tokenizer from the scratch. Suppose you want a tokenizer which behave exactly like Llama, same normalization, same pre tokenization, same BP model type, but train on domain specific corpus, medical text, legal document, a new language. In before, this required manually reconstructing the tokenizer pipeline from low level tokenizer library primitives. In V5, you can insert the library architecture directly from the train. Loading the dataset, getting the training corpus, and train from the we are training the it from the iterator. We are specifying the vocabulary size, we are specifying the length of document, so it's progress means this showing the progress of the how much the tokenizer is being trained, how much time is replaying, and progress of the tokenizer being trained. And we can also post the tokenizer in the GitHub, the sorry, in the Hugging Face Hub. The resulting tokenizer will have the custom vocabulary and merges rule, but will process the text identically to how standard Llama tokenizer would in with the same white space, handling special token convention and same decoding behavior. Aspect files per model. Before 2 means tokenization ex.py, tokenization ex fast.py. 1 tokenization ex.py. Default backend means split between the Python and Rust in the B4. In B5, Rust backend by default and is preferred also. Architecture visibility hidden in serialized file, explicit in class definition. Training from scratch required manual pipeline construction. In B5, simply tokenizer to train. Component inspection difficult, undocumented, direct tokenizer normalizer, parent classes, pre-trained tokenizer fast, tokenizer backend or syntax or Python backend. The shift from the tokenizer as loaded segment to the tokenizer as the configurable architecture makes the library more modular, more transparent, and more aligned with the how practitioners think about building the YAML system. Summary: the Transformer B5 brings the three important to the improvements to the tokenizer. One file per model, instead separate, slow and fast implementation, visible architecture so you can expect normalizers, pre-tokenizers and decoders, trainable templates that lets you create the custom tokenizer matching any model design. The wrapper between the tokenizer and transformer remains essential. It adds the model awareness, context length, chat templates, special token, and raw tokenization does not provide. B5 makes the layer more cleaner and customizable. This is for today. It was quite a bit new to me to read it here, and I've been reading for almost 39 minutes, and my mouth is more becoming drier because I do not use only read this much loud here. Anyway, thank you for watching. If any of you are watching, see you next time.